All right, hello everyone. Welcome back. This is our last video series of the semester, so let's get to it. All right, so this week we're going to be working on the chi-squared test. All right, we're going to talk quite a lot about chi-squared test, so let's get right into it. So we're going to start off by talking about the broad category of tests that chi-squared tests belong to, that is non-parametric tests. And chi-squared is the only example that we're going to get into, but there are several other non-parametric tests. But in order to talk about that, we're going to have to start by going back over stuff we've already talked about, all right? Now, we began this course, really the middle chunk of this course was about group comparisons, okay? Now, we started off with our z-scores, our z-tests, and our one-sample t-tests over here on the left. And these were not really actually group comparisons at all. These were all about comparing individuals to a population, all right? But then when we started separating our participants into groups, we had first our independent and paired samples t-tests. Those were when we have two levels of our independent variable. If we had more than two levels of our independent variable, then we moved over to one-way ANOVA. All right, we have independent measures ANOVA and repeated measures ANOVA. Then, after that, we moved over to multiple independent variables. We stuck with only two independent variables in this class, but really you can go up to any number. It's not really advisable to go much past 4, though. All right. So again, we have independent measures and repeated measures, but because we have multiple independent variables, we also have the potential for a mixed model ANOVA. Okay. Then we moved over to correlation. All right. Now in correlation, we test two naturally occurring variables. In this case, we have age and weight, and we want to know if they're related to each other. Age and weight happen to have a positive correlation, which means as you go older, you also tend to get heavier, all right? And that's why this line goes in an upward direction. If it was the case that the older you got, the less you weigh, maybe that's true like at the end of life, then the correlation will go downward like that. Younger folks with relatively high age, younger folks with relatively high weight, and older folks with relatively low weight. All right? So up until now, all of these tests have used hypothesis testing to learn about group parameters, all right? We haven't talked about parameters in a long time, so we're going to do a quick refresher here. And when you think of parameters, you should also think of statistics, all right? And that's because parameters and statistics are actually the first example of a sample versus population set of things that basically mean the same thing, but different versions, all right? So in one sample t-test, our null hypothesis was mu of whatever our treatment group is compared to the population mean. In paired and independent samples t-tests, we had two different population means, so mu of group 1 and mu of group 2. In ANOVA, we added another one, so we've got 3 different mu's there. In correlation, we moved away from mu, the population mean score, to rho, the population correlation value, all right? Now, these are all a little bit different, but what they have in common is they're all parameters about the population, okay? So in each of these examples, we used sample means or sample correlation to try and estimate these population parameters, okay? We tried to guess at the population parameters. And that's why these are called parametric tests, because they're trying to get at population parameters, okay? Now, what is the case with these types of tests is they require certain types of data, all right? Either interval or ratio data. Now, what I want you to remember about interval and ratio data is these are both types of data that you can put on a number line, all right? So interval data means there's equal intervals between the points, maybe 1 inch, and then between these 2 points, also 1 inch, okay? So there's equal intervals. The only difference between interval and ratio is ratio has a meaningful 0 point, which means none, all right? Whereas interval does not have a meaningful 0 point. That 0 point is kind of arbitrary, all right? So data on a number line is a great example of interval or ratio data. Now, unfortunately, this kind of data is not always available to us, all right? We don't always have stuff that we can put onto a number line like that, all right? And if it's not available, we're okay, because we can just run a non-parametric test, all right? Now, chi-squared is the only type of non-parametric test we're going to run. And before we get too deep, I want to try to talk about how to pronounce chi-squared just a little bit, because students often have trouble with this. I know it looks like chi over here, and it looks like x over here, but it is not chi-square, and it is not x-square, okay? It's very important. This x-looking thing is not an x at all. It's actually the Greek letter chi, all right? That's why we call it chi-squared, okay? Now, when you're pronouncing chi, you should basically pronounce it like the first syllable in kayak, all right? Kayak, chi-squared, okay? In fact, this is such an issue that I kind of want you to say it out loud. I know we're not in person, but in the future it could come up, and I don't want you to say chi-squared and people don't know what you're talking about. You want to keep that communication as effective as possible. So let's try it together. Chi-squared, all right? So why might we want to use a non-parametric test? Well, honestly, we don't really want to. If you've got a choice between parametric tests or non-parametric tests, you're almost always going to go with those parametric tests. They're just better, all right? They're more precise. They're also more powerful. You can get nice exact numbers. It's really good, all right? But there are certain times where we sort of need to use non-parametric tests. I'm going to turn the light on because it's getting real dark back here. Maybe it's just a little dark. All right, so if given the choice, when would you choose to use a non-parametric test? Well, sometimes it's a little bit easier to use ordinal or nominal data. Now, as a quick reminder, these two types of data are data that you cannot put on a number line, all right? So nominal data is name only, so like female versus male. There's not a direction between them. There's no line. There's no intervals between them. They're just different, okay? And then ordinal data, like they have an order, but they're not a specific distance from each other. So maybe like first, second, and third, all right? And so sometimes it's easier to use that kind of data than it is to use interval or ratio data. One reason you might want to do this is when exact measurement is difficult or it takes too much time. And you might also have some problems with different types of variables where you would want to use an interval data, but it doesn't work that well. So timed variables can be on a interval scale, certainly. They can also be on a ratio scale, actually, because there is a meaningful 0 point. Let's say you're talking about time to finish. There's a meaningful 0 point, so you could just put the average time to finish. You could be interested in that. But there's some problems with this. You might have extreme outliers. If somebody breaks their leg during the race and then they take maybe an hour to finish a single mile race, well, that's going to mess with your data quite a lot. Also, sometimes you have participants who don't finish. And if they don't finish, then it's unclear what time to give them. Any time you give them will be really an underestimation of how long it took. But if you switch over to ordinal data, you can just put them in last place, all right? And then you don't have to worry about it. So we're going to be talking about two different chi-squared tests, all right? The first test is called a goodness of fit test, and the second test is a test for independence, all right? So I'm going to deal with this light situation and then we'll come back, all right? So that's all for part one. We talked about parametric and non-parametric tests. Remember, parametric tests are using things like mu or rho, really trying to estimate mu or rho. Non-parametric tests do not use these population parameters. Instead, we're going to use other things. We're going to use either ordinal or interval data that can't easily be put into correlations or even average scores or even mean scores, okay? We're going to start off by talking about the goodness of fit test, and then we'll move on to the test for independence. These are our two different types of chi-squared tests. Remember, like kayak, all right? Before we get to the next video, I want you to go grab your chi-squared table because we're going to be using that. All right, I'll see you then.